All right, and welcome back to Unit 3 Scatter Plots, Exploring Bivariate Data. Today, for your Do Now, hopefully you were able to go on IXL and practice point slope form. It's probably been a little while since you've actually used point slope form, and we're going to need it today as we are going to be calculating lines of best fit. So we're going to try to fit a line to our data points. And then, of course, you're going to get some practice time. There's some practice problems on your sheet today. And then Khan Academy is also the resource we're going to use to practice what we learned today. Please remember, when you're doing Khan Academy, you can practice those problems as many times as you need to get the grade that you want to earn. So a line of best fit is AKA a trend line. It is also called a linear regression line. And basically what you do is you try to fit a line in the middle of your data points. And what you want to make sure is that you hit as many data points as possible, and there are equal amounts of spaces of data points above the line as below the line. And obviously, as we talked about in Unit 1, if you have an outlier, say you had a data point out here or one over here, you don't necessarily need to include it in your line of best fit. That would be an outlier. It's going to skew the data a little bit, but we want to try to fit most data points with a line. Okay, and we're going to look at our example of temperature and ice cream sales again. So this is a very good line of best fit. Here's another example. This is sea level rising, and these are different years. And you'll notice this might be related to, say, global warming, that as the years have increased, so has the sea level. This is a data, and I would say that this has a strong positive linear association. And here we can go ahead and draw the line of best fit. Again, you're going to want to try to even it out and have as many data points on top of your line of best fit as you do on the bottom. So I would say that's a good estimate for what the line of best fit should look like. So that's step one, is being able to draw a line through your data. You might want to use a straight edge to do so, or a ruler. So here we're going to go ahead and look at a line of best fit and see if we can go ahead and write the equation for the line. So we're given 2 points here. Now, what's interesting is that on this particular graph, we were able to actually find 2 data points that are on our line of best fit. When you are selecting your 2 points, they don't necessarily have to be data points, but what they do have to be are 2 points that are actually on the line that you drew. Okay, so we're going to use this point here at 12 and 180, and we're going to use this point up here, 25 and 610. I could not use this point to calculate the equation of the line because this point is not on the line. I could not use this point to calculate the line of best fit because it is not on the line. I could have used this point right here, but I chose to use these 2 points. Okay, so step one, we drew the line. Step two, we're going to choose 2 points that are on the line of best fit. All right, step three, we actually have to calculate the slope. Okay, so the first thing we're going to do, like I said, is calculate the slope. And so to calculate slope, it's y2 minus y1 divided by x2 minus x1. So essentially it's your rise over your run. And so y2 is 610 minus 180, that's y1, and that comes out to 430. And then you take 25 minus 12, that's your x2 minus x1, and you get 13. And then I've divided and estimated it as about 33.1. So I rounded, so it's not going to be exact, but it's going to be close. Excuse me. So that means there is a 33.1 rise every time the temperature increases by 1 degree. We're expecting to make $33.10 every time the temperature increases by 1 degree. So then what you're going to do is take this and put it into point slope form. And again, I know it's been a while, but point slope form is y minus y1 equals m, which we just calculated at 33.1, x minus x1. Now for this you can choose either point and you'll come up with the same answer. I've chosen the point 25, 610. So the key for this formula is that you put the numbers in the correct place. So your y1 in this case is going to be 610. Again, your m, or your slope, is 33.1. And then your x is going to be 25. To complete this, the first thing you're going to do is distributive property. So 33 times x is 33.1x. 33.1 times negative 25, that gives you negative 827.5. Now we have to move the 610 over by adding it, inverse operations, adding it to the negative 827. And what we'll come up with, our line of regression, or our trend line, also known as your line of best fit. This has an equation of y equals, so we can expect our sales to equal $33.10 times the temperature, and then take away $217.50. This might be our startup cost or whatever it is. And then we should be able to make a prediction at any temperature what our sales are going to be, simply by plugging them in here. If we take this and say we plug in 24 degrees, we would simply do 33.1 times 24. Let's go ahead and do that in our calculator. 33.1 times 24, and you get $794.40. But now we're going to take away the $217.50, and we should end up with a profit at 24 degrees of about $576.90. If we scroll up, we can clearly see that this point right here is approximately $576.90. Though we couldn't predict that exactly just by looking at the graph, we can definitely use our line of regression equation to do that. Now, when we were calculating correlation coefficients, I showed you how to calculate the line of regression. For this particular graph, we only have 2 points. So what you can actually do with these 2 points, I'm going to take us back to yesterday's video, how to calculate the correlation coefficient, except this time we're going to stop after step 2. So what you're going to do is enter your data in L1, and all you have to enter are those 2 points, the 2 temperatures, 12 degrees and 25 degrees. And then in L2, you're simply going to calculate, or you're going to put in $180, $610. So L1 has 2 data points, L2 has data points. Then you're going to hit Stat, scroll over to Calculate, hit 4, and when you hit Enter, you should notice your regression line. You should notice your slope is 33.0769, blah, blah, blah. And your B value is going to be negative 216.9. Now for our B value, where is it? Let's see. For our B value, we had 217.5, very close. And that's simply because I rounded to 33.1. But you should end up with something very close. So you can calculate it by hand using slope formula and point slope form, or you can simply put it in your calculator and let the calculator calculate the line of regression for you. Okay. Now, where is this useful? So let's go ahead. We talked about interpolating and extrapolating on Monday. So now we can actually use the formula to interpolate. So we're going to round yet again. So we're just going to say that Let's round it to 33x, and let's round the 217, let's round it to 216. When you use 33 as your slope, 216 will be your y-intercept, negative 216. So if I wanted to know the sales value at 21 degrees, 21 is my x value, it's my temperature. So I'm going to plug it in the formula for x, multiply it by 33, subtract out the 216, and I should see that 477 is the amount of sales that I should be able to estimate that I will make on a 21 degrees Celsius day. And if you look on the graph, 21's here, scroll over, and yes, 477 is right here. Now, if this is also helpful if I have a graph, graphs are useful for the snapshot of the data that they're displaying. However, what if I want to know a temperature that's not on the graph? That's when I've got to extrapolate information. And so I'm going to look at, let's say, 29 degrees. Obviously, my graph stops at 26 degrees. So I'm going to plug in 29 degrees to my awesome formula that I just calculated. And so 33 times 29 minus 216 could predict that I'm going to make $741 on a 29 degrees Celsius day. So extrapolation is okay, but again, it's a prediction, so we can't say for certain that that's going to happen. We're just saying based on the data we have, we can predict that that is most likely going to occur. So we're going to go ahead and play a couple quick games of Kahoot together in a little bit. But before we do that, I'd like to show you how it's going to look on Khan Academy. So on Khan Academy, you're going to have to determine which is the best line, or is it none of them. And so if I look at these points, obviously it's not going to be C, because for line C it's saying that it's a positive graph, but I can just look at this data and I can indicate that it's mostly negative. So I'm going to have to ignore C. Now if I look between A and B, B is an excellent line if the data points in A do not exist. And A is an excellent line if the data points for B do not exist. So I would say the best trend line would be something kind of in between both A and B. So for this particular situation, I'm going to say that none of these lines are a good estimate of the data. Because remember, for a good trend line, you have to have the same amount of data points above as below. And if we use A, all these data points down here are below the line, but there aren't very many above it. And if we use B as our line of best fit, all these data points are above the line, but there aren't very many below it. So this would be a none of the above. None of them are a good line. All right, let's look at another example. All right, so I just chose the 2 points, 224 and 420. As you can see, those are points that are on the line of best fit, but they're not necessarily data points that TESS collected. So those are the 2 points I selected. And then I just put them in my list. List edit, I put 2 and 4 in list 1, and then 24 and 20 respectively in list 2. Went to stats, scrolled over to calculate, hit 4, and the line of regression that I came up with was y equals negative 2x plus 28. Now the second part of this question is that I want to know the date in April her flowers will bloom. Okay, so if the March temperature is 5.5 degrees Celsius, I'm just going to simply plug that in the formula here for x. So I'm going to do negative 2 times 5.5, and that's negative 11 plus 28. So I can say that it's probably going to be on the 17th day of April that she's going to have the first bloom. And that would be it. And let's see if that works out. So 5.5 is approximately here. I scroll up, and sure enough, that's at 17. Right here at 17. All right, so those are the kind of problems on Khan Academy. Enjoy.